streaming at hours that were like demon hours for the US, but normal hours for like, you know.
And that's
Saudi Arabia.
badass. I love that.
Yeah. Oh wait,
Hey,
you
bro,
guys,
it's so fucking cold. They got me wearing a fucking hoodie. I swear.
wait, it's cold in Houston, dude. What? It's cold in Houston?
It's cold in Houston.
Oh damn. It's pretty chill. It's pretty.
I got you.
Yeah, there you go. There's Ramiro, dude. What's up, Ramiro?
Face on live.
There you are, Ramiro. What's going on, dude? Yeah, no, it's fine in Houston right now. It's beautiful in Houston.
Yeah, bro, I'm freezing over here. Well, I'm in Willis, Texas right now.
Okay. Willis, Texas, he says, yeah.
Yeah, I'm in Willis right now. I drive.
Oh, is that up north? That's got to be up north or something.
Yeah.
No? Nice.
Yeah.
Cold boys.
All right, guys. This was the once in a while time to show my beautiful face. The lovely opportunity y'all had. Who knows when y'all will get this opportunity again.
I appreciate that, Ramiro. Thank you, dude. Appreciate you, dude. Ramiro's one of our oldest students, or longest time students. Not oldest, like not age-wise, but he's been here the longest, probably.
Yeah, I just look oldest, look-wise.
Look-wise, there he goes. I look old too, man. I look weathered as fuck. I'll show a picture of me. I have a picture of me from like when I was a lot younger on Instagram. I just posted it today.
Bro,
it came up.
I've seen those pictures, bro. It got me laughing my ass off.
Did you see that? Yeah. Where is it? If I look at my profile, where's me, Dr. Gold? Like the only person I follow, I think. Yeah. Yeah. What was it? This was me bitching about my internet. But there you go. That's me in 2012. That's 13 years ago, at APS DPP. So this is a physics conference I was at, and I was presenting a poster.
Low-key, bro, it looks like we got hit. It low-key looks like we got hit with the wither effect from Minecraft.
I know, dude. Right? The wither effect. Is that what it is?
Yeah.
Damn. Low-key be getting hit like that. All right. Nice. All right. I'm gonna start doing this question, Ramiro. But thanks for stopping by, dude. You're a G.
Yeah.
Hell yeah, dude. All right, let me get my TikTok chat working. I want like the Wii music, dude. Except they would like shut my stream down right away. Yeah. All right, let's see. JEE to start. I mean, that's what's in the queue, dude. That's what's in the queue, unfortunately. It is JEE. Yeah, I fucking hate these questions, but whatever. All right, the distance from the origin to the centroid of a triangle whose two sides have those equations and whose orthocenter is Rex is like, hell nah, dog.
That's dope.
I know, dude. I know. It's pretty trash. Excuse me. Sorry.
I just went into the chat, and the first thing I see is, "Oh my god, you looked so nerdy." Are you finna let them talk to you like that?
I was nerdy. I'm still nerdy, dude. I'm the nerdiest, dude. Yeah. You should rock the hairstyle again. I don't have the hair anymore. As I get older, the hair's gone. Yeah.
He can't grow it no more.
Can't grow it no more. Yeah. That's what happens as you get older.
After a certain age, it becomes impossible, especially once you become Gold's age.
Yeah, I'm up there, dude. Getting really old. Orthocenter is where two altitudes meet, but also any two also meet there. So there's like perpendicular lines, right? So if we have the equations here, I feel like we can find what the perpendicular lines would be and then have them meet, right? Yeah, right? Okay. I feel like that's right. And I should probably find intersection points too, yeah? I wonder if I can fucking find the third line. Oh, wait, and then that's the orthocenter. Oh, this is gonna be an interesting systems of equations, right? Right. Okay. Let's do it. Sketch the graph. Always a good start. Yeah, let's do it. Okay. So from this one, if I move this over and divide by 2, I get y is equal to 1/2 x plus 1. Cool. And then from this one, I get y is equal to 2x minus 1, right? Okay. Not bad. So let's graph what that looks like. 1/2 x plus 1. So that means we start here and we're going up by a half. So it looks like that probably. 1/2 x plus... Oh, yeah, sorry. Plus 1/2. Yeah, that's what I meant to say. Sorry. You right. Yeah, I got to divide everything by 2. Already making mistakes today. But Jeff, you're here to save me. I appreciate it. Okay, there we go. So we got this. And then I got 2x minus 1. Okay, so that looks kind of like this then, right? Well, actually, these are almost negative reciprocals, but not quite. Okay. You know, I'm gonna like blow this out a little bit. There we go. We're gonna do like this. I just want to make it look bigger. Right, something like that. And then they say the orthocenter is at 7/3, 7/3. Okay, so that's like right here, I guess, right? Well, 7/3 is... Wait, 1/2... 7/3 is more than a half, right? Wait, what the fuck? Excuse me? Yeah, how does that work with this, though? Oh, I guess... Well, let's figure out where these intersect, actually, real quick. Let me just do that. 1/2 x plus 1/2 equals 2x minus 1. So we get that negative 1/2 is equal to 3/2 x. We don't know where the third side is. That's very true. But from this, I get negative 1 is equal to 3x. So x is equal to negative 1/3. Interesting. Wait, so they intersect way back here? Sorry, what? Did I do it right? Am I already fucking up, Jeff? Dude, what's going on? Yeah, no. 3/2 x minus a half. Cool. Yeah, x equals negative 1/3. So I drew these totally wrong. Or something. I think because this is like really, really far down. You love my strings? Thank Conjure. Appreciate that you love them, dude. How can this help? How can this math help me? 6.9 underwater deep sea where every cubic inch holds a ton of pressure? I don't know. Well, it would probably fuck you up, honestly. No. Wait a minute. You know, I'm just going to graph this real quick. Where's my calculator? Let's go find my calculator. I need to make it gold first. Wait, negative 1/2 minus 2 is it negative 3/2? Where do we get that? Oh, from here? Oh, you know what? Yeah, I am fucking that up. Sorry. I totally mixed. I mismatched this. Yeah, okay. I was looking at this. I'm like, this doesn't make any sense. My bad. Okay, sorry. This is negative 3/2. And then 0 is equal to 3/2 x. Oh, okay. Oh, so x equals 1. Thank you. Okay, that sounds better. Okay, that kind of makes sense, right? If this is like a half and it intersects at 1. Right? 1, 1. 1, 1 is the intersection. Yep. But what's weird is the orthocenter is outside of this. Right? 7/3, 7/3. Oh, I see. I see what happens. So that's like over here, up here. This is the orthocenter. Yeah, so it's on the other side. Man, that's a bitch. Really? Did they do that to us? Okay, so this is really the triangle. I see. Okay. And this is the orthocenter. Okay, cool. I'm thinking I want to set up like a systems of equations where there's an equation for what's up, Rex? There's an equation for distance from a point to a line. Right? Let me see if I remember how it works. Sorry. Let's get the equation. I just want it. Distance of point to line 2D. What is the equation for that? Well, hello. What's up, JC? What do we have here? Yes, I normally just use calculus. Yeah, so... the orthocenter is that. So, the distance from the center to each line needs to be the same, right? So... Andy says, you helped me answer my Physics 1 practice final first year of college 2 years ago. Oh, you're very welcome, dude. Appreciate you coming by, dude. What are you up to now, Andy? 2 years ago. Yeah, there's a lot of time that's passed, right? I'd recommend dropping a perpendicular from the orthocenter to one of your lines. Then, where this perpendicular intersects on the other line will be a vertex of a triangle. Ooh, Junior Civvy. Nice, dude. One of my best friends was a Civvy. Building bridges and shit. Concrete. That's fun stuff. Okay. Dropping a perpendicular from the orthocenter to one of your lines, and then where this perpendicular intersects the other line will be a vertex of the triangle. Is that true? I mean, let's just say like the line's like this, right? Sorry, if I drop a perpendicular line to this, does that necessarily... I don't think that... Does that go to the vertex of the other one? Sure it does. I was going to brute force this with... by definition... Okay, well, let's see. Let's see what they talk about. Sorry. I need to see what an orthocenter is. He is right. Thank you. Yeah, okay. The third altitude must always... Okay, so they always intersect at a vertex. That's super cool. I learned something today. Dude, all these little triangle properties are always so funny. I can definitely help with Extrema. If you want to submit a screenshot to our queue there, actualofficehours.com, I'll do it. Okay, so this is cool. The perpendicular line to a side, which is called the altitude, because it goes to the vertex of the other two sides, also passes through the orthocenter. So I just need an equation of the line that's perpendicular to this. It's weird that many of the three crossings intersect at a single point. Yeah, I guess that's why it's called the orthocenter, right? So let's figure out what this is, right? If I have the equation of this line, then I have that. And then what do they want? The distance from the origin... Sorry, the distance of the origin... Okay. Oh, distance of the origin from the... Sorry, what the fuck is this even asking, dude? Oh, from the centroid. Oh. Okay, but what the fuck is the centroid? Is where the three medians intersect? Oh my god, dude, what?
Surprise, motherfucker.
Point to midpoint of the other side. Dude, this is just a bitch. It just sucks. I agree you need the third side, though. You need the third side in order to do this. Yeah, it's just tedious, which is, again, what they're trying to do to see who really wants to escape poverty in India. They're like, how badly you want it, dog. Because it's just tedious. Again, there's some cool concepts here, I guess. Nice lineatrix. Here, did you just get the equation of the line for me? Did you do that? What is it? It's y is equal to 6 minus x. Is that it? It's pretty cool if that's it is. But we can do that real quick. Sorry. This one was... this one, right? Okay, hopefully it works. Well, let's see. So perpendicular to that line is going to be y is equal to negative 2x plus b. And then it needs to pass through the point 7/3, 7/3. So you have 7/3 equals negative 2 7/3 plus b, right? I think that's right. Okay, cool. So that's negative 14/3. So add that over. You get 21/3 is equal to b. So b equals 7. I think that's what you had, right? Wait, you had x minus 6. Uh-oh. Did I do something wrong there? No. Equals 7, yeah. Okay. Okay, so the equation of that line, the purple one, is y equals negative 2x plus 7. Okay, cool. So that's this. And then I can figure out where the intersection of that is with the green one. So I'm just going to set that equal to 2x minus 1. And what are we going to get? We're going to... Oh, I see what you're saying, maybe. So 8 is equal to 4x. So x equals 2. Y equals 3. Cool. All right, so this was 1, 1. This is 2, 3. And then I need this one as well. So let's have that intersect with the other one. So let's do negative 2x plus 7 equals negative. Sorry, what's the red one? Sorry, what was it again? 1/2 x plus 1/2. What's up, Amon? Oh, I don't like all these halves. I definitely can, Bryce. If you want to submit a question, I'll do it. So this is negative 5/2 x is equal to 1/2 minus 7 is 6.5, so 13/2. Okay, so negative 5x equals 13. I don't like that. But okay, fine. X equals negative 13/5. Is that right? 2x plus 7. 1/x plus 1/2. Yeah, 5/2 equals 13/2. Yes. You're right, user credit card number. That's a cool username. Partial derivative. Submit a question. I'll do it. Submit a screenshot. 1/2 minus 7. Yeah, so what I did was I moved this over. Oh, sorry, this is positive 5/2. And then this is that. Okay, cool. Sorry, it's positive. Yeah. Thank you. I think that's right. Right? There we go. Okay, x equals 13 over 5. And then that means y is equal to 1/2 times 13 over 5 plus 1/2. Okay, so that's 13 over 10 plus 5 over 10. So 18 over 10. Oh, so 18 over 10 is 9 over 5. Okay, so that's the other point. 13/5, 9/5. Okay. And then they want the centroid, which... Oh, man. Now I gotta find an equation of a line here, and then another equation of a line here, and then find that intersection, and then find that distance? Is that really how I have to do this? Oh, man, dude. What? You poor people in India, dude. I feel for you guys. This sucks. When will I ever use this in real life? Manny says parallel axis theorem. Wait, that's for physics. That has nothing to do with this question. Parallel axis theorem? What? What's up, Baka? Just find the midpoint of each side? Alright, let's do it. Says there could be a trick. Join the vertex closest to the origin with the orthocenter and extend it until it meets the third line. What do you mean by that? Does it help the centroid? Maybe. You know what I'm gonna do before like I go really, really much further? Let me just see if ChatGPT has like an easy way to do this. I know the brutal way to go do this, but I don't want to do that. But let's just see. I'm gonna use chat as like inspiration to see what it does. if it does something, the Pappus theorem. What the fuck's the Pappus theorem? Y'all just like saying random names to me now. The most tedious shit ever. It really is. Let's just see. I'm curious what chat tries to do. I need the centroid coordinates, and then I'll calculate the Yeah, so how do you get the centroid coordinates? Is there some fancy equation for it? We got all the vertices. What's good, smart people? What's up, clickbait? There's a formula? Okay, here we go. Oh, if you have the coordinates, you just average them? Is that really what you do? Which coordinates do you average, though? Interesting enough, they got different points. What did we get? We got 1, 1, 2, 3, and then they got 3, 2, which I'm tempted to say is better. Yeah, I like the 3, 2 better. What did we fuck up here? Sorry, 1/2 x plus 1/2 with negative 2x plus 7. What did I screw up here, Jeff? If I move that over, that's 5/2, right? And if I move that over, that's 6.5, right? I get x equals 13/5. And 9/5. They somehow got 2 and 3. What? How? Oh, the bottom isn't my vertex. Thank you. Thank you. Thank you. Yeah, sorry, I forgot. This is an altitude. To find the last vertex, you have to go the perpendicular the other way. Thank you. Correct. See? Good thing we didn't go down this. This was wrong. All right. Again, this is why AI is useful, because it can prevent you from making a bad mistake and doing shit you don't really need to do. All right, so we found the altitude. So the next thing is to find out the third vertex. Yeah, good. Which needs to be something like this, right? Where I could find the perpendicular line from this that passes through that. Okay, cool. Let's just do it. We're so close. I just want this one at this point. Okay. So let's do this in like the blue. Whatever. I'm gonna say it does. I know that's not 90 degrees, but don't yell at me. Okay, so perpendicular to that, so that's y is equal to negative 1/2 x. Actually, no, you guys don't like this color, remember? Sorry, let me just choose a different color. We're running out of colors. We're gonna do brown. Yeah, just pretend that it goes through there or something. Oh, the farmhand one? Yeah. Yeah, yeah, I say don't account for friction because the work done by the farmer is not the net work done on the object. That's the difference. Okay, let's get this line. If you want to submit the screenshot again, the queue's only 4. So, Ahmed, if you just want to just put the screenshot in and I'll do it. I'll do it again. Y is equal to negative 1/2 x plus b. And then it needs to pass through 7/3, 7/3. So 7/3 is equal to negative 1/2 7/3 plus b. So then this is 7/3 plus 7/6 is equal to b. So what is it? Oh, that's 21/6 is equal to b. Okay, so you get y is equal to -1/2 x plus 21/6. Okay, and then that needs to intersect with the red line, which was 1/2 x plus 1/2. Which, in terms of sixes, that's 3 6s, right? Okay. So now if I move that over, I'm going to get 18/6 is equal to x. Cool, x equals 3. And if x equals 3, then 3/2 plus 3 6s is y is equal to 2. Okay, cool. So then this is 3 2. Okay, I agree with ChatGPT so far. Yeah, nice. Those are good pictures there, Joseph. Yeah. Yeah, dude, that orthocenter is pretty ugly, right? All right, this is 3, 2. Yeah, nice. Yeah, nice. Yeah, that's exactly where it is. Yeah. Okay, so then the centroid is just averaging all the coordinate points together. So I do 2 plus 3 plus 1 all over 3, comma 3 plus 2 plus 1 all over 3. So that's 2, 2. Beautiful. And then what's the magnitude of that? It's the square root of 8, so it's 2√2. So this is the centroid. And then the distance is equal to square root of 2 squared plus 2 squared equals the square root of 8, which equals 2√2. Nice. Answer choice C, which I think is what ChatGPT got as well. You have 5 people in voice chat confused? Okay. Nice. Okay, good. Good question. One sec. I need to fix. OBS has the weirdest time figuring out, like, which window is Discord. That window is Discord. So what we're going to do is I'm going to post that question over. Why can they be use the same problem? Because they're great. Any right triangle can use sine, cosine, and tangent. You just have to pick different sides. Okay, so that question goes here in office hours help. That is from Naranjan. So here, I'm going to save that photo for you. Well, why don't you save it? Sorry, save it. There we go. Ninja. And then that's going to get put right here as a solution. So there you go. Ninja run. If you're watching, there's your question. Cool. All right, let me go back to my channel here. Pop this out. Okay, cool. I guess if it's multiple choice, there's intuition you can use if you don't have to prove all this. So yeah, I mean, this is, if you don't solve this within 5 minutes, you go back down to the cow patties. That's how JEE works. It's fucking awful. Okay, here, Ahmed, I'll explain your question real quick because you did ask yesterday. Sorry, and I had kind of had some time to do it. I'll do it right now for you real quick. This one. You're on the right path, Ahmed. 3 minutes max is what you get?
Surprise, motherfucker.
Bro, that took me like at least 10, maybe 15. Yeah, I don't envy you guys. Okay, a farmhand does 972 joules of work as he pulls an empty hay wagon across a level ground with a force of 310 newtons. Okay, cool. So, here is the block, which I don't really know what's happening to it. I don't know the mass of it, at least. But I do know it's getting pulled at a force. It's weird he's pulling it down, but sure. Okay. So this is 310 newtons. And then this is going to be 23 degrees below the horizontal, right? Yeah, who pulls a wagon like this, dude? What? You usually pull it up, I don't know who's pulling it fucking down. Oh. Quantum for 7 hours. Jesus. I don't envy you. Okay. So that's the farmer. Okay. And then here's the key thing. So the farmer is... I don't know. He's like underground pulling... I don't fucking know, man. He's... Let's pretend he's here and he's like pulling it down. Okay. Whatever. Okay. But the farmer, right? I assume the farmer moves the same distance that the wagon does, right? We assume that they're connected to each other. Really big wagon, really tiny farmer. Yeah, okay, here. You want to like put... You're going to put like really tiny farmer in here. There he is. He's pulling it, okay? All right. If we talk about the... And then here, let's make a different color for the farmer. Let's make him red.
Nice.
Yeah. Really tiny farmer. So he is pulling in this direction, okay? So let's think about like what the work that he does, right? Because they say this. They say a farmhand does that many joules of work. So that's the amount of force that he applies times the distance he applies, right? So he's pulling with a force of well, we don't know. Well, the force is 310.
Nice.
The jerk equation? Yeah, no. What's up, MX Plixed? Yeah. 310, and then the distance he's moving is in this direction, so I only care about the x component of this force. So that's going to be cosine 23 degrees times the distance he travels, right? And that's the work done by the farmer, right? That's how much work he does, okay? That's not the net work of the farmer, right? Because the farmer also has tension in the rope acting on him to the left, right? And this tension is probably related to like the friction and stuff. But what they also say, right, is that the wagon, we assume it travels at constant velocity, I guess. Cosine, yeah, why is it cosine? Okay, because if this is the hypotenuse and I'm moving in this direction, then I care about my force that's also in that direction. So if this is a right triangle, cosine is the adjacent side. Right? That's also... dot product is also cosine, right? FD cosine theta, yeah. Okay. But they say this is equal to 972 joules. Just off the rip, right? So this is the force. The distance is equal to D. So then F dot D, which is equal to the work done by the farmer. It's the inner product. What's up, Zach? So this is just equal to 310 cosine 23 degrees times the distance. And then that needs to be equal to the 972 joules of work he does. So you don't even care about friction. The friction's a red herring. If you want to talk about how this work is distributed, then yes, now the friction does play a part. Because if there was no friction, then all 972 joules of work he does would get put into pulling this thing. But instead, 280 newtons, which is going to be part of the work, is being robbed by friction. Does that make sense, Ahmed? Right, this is the force of friction, which is equal to 280 newtons. So if you want to figure out the work, the distance that the farmer travels, right? Yeah, that makes sense? Okay, cool. Here we go. So then D just equals 972 over 310 cosine 23 degrees. I mean, honestly, this question is written badly because they should have said network. That's usually how this is done. Yo, my classmate. Oh, you guys are all watching? Nice, dude. Welcome. Okay, so... what is that? 972 divided by... Also, bad question, because again, who pulls a wagon like that? Yeah, right? What? Some weird ass wagon pulling, dude. Cosine 23. Okay, cool. So yeah, it should be 3.4 meters. Which I think is what we said, right? Did we say it was 3.4 meters? Yeah. Maybe that's what JEE teaches how to pull a wagon. Yeah. So yeah, your 180 meters was assuming that that was the network that the farmhand does, or the network acting on the farmhand. But the farmhand has the force of tension in the rope, which is fighting him, and then he also has the force that he's pulling at. But they're referring to just this.
This is the work he does, and then these two things together is like the network acting on him. Or I guess it's also like the network acting on this. Yeah. The network on the box is this 310 cosine 23 degrees minus this 280, which I think is what you had here. And then you do 972 divided by it. Yeah? Cool? On the go? Nice. Alright, awesome, dude. Great. That makes sense.
Hello.
What's up, Ranson?
How you doing?
Good. I was fixing. You're good. You're good.
Went outside to run some errands because I didn't know when you were gonna message me.
Yeah.
But yeah, I messaged you. I think tomorrow or Friday we should be able to find a time.
Friday is great. Let's do Friday because my Friday is totally open. I don't stream. It's Halloween, but whatever. I don't stream, and
I'm like
I don't
like 10 p.m. my time. So
no. We don't have to be till. Yeah. No. Yeah. It's good. Friday will work. Yeah. Just message me. We can do Friday. Yeah.
Perfect.
Who is this? Ahmed's one? Let me get this question for him. How big does the wagon need for the curvature of the earth to make the force, dude? No, don't do it, dude. Is that how we make this a JEE question? We start taking into effect the Coriolis effect or something? I don't know. All right, Ahmed, I'm gonna put this in the stream for you as well. Sorry, in the Discord. So if you look right here, there you go, Ahmed. There's your question. So, also here, I'll give you a bond coin because you did ask a question. That does count as one. Ahmed. Well, which one are you? Which? Ahmed. I think you're this one. If you're not, just let me know. Did I try that physics question? Which one, Drew? From yesterday? We had a lot of questions yesterday. I went through, I want to say 30 last night. Okay, spice and chicken nuggies. Oh, and this was Ahmed's. Okay, so I can delete 5. Really struggling with these. If you can help. Okay, Charles, I'll help on like which. Charles, you tell me which one you want me to help you on. Like you get to pick one. Spicy chicken nuggies. Ooh, okay, this is cool. I like these. This is like a little geometry. Difficulty hard, they say. Triangle's my beloved. Dr. Gold, did you take away friction in that calculation? Yeah, you don't need friction because they talk about the work done by the farmhand, not like the network of the farmhand. I guess. Yeah. That's why this is poorly worded. You don't usually when this question is asked, you talk about the network done on the wagon and then you do include friction. Yeah, it's either intentionally trying to trick you or someone just doesn't know English. Where do I find where you sent it? It's in homework help. So in this forum thread here, homework help, you'll see all the channels, and then you should see. I think I spelled your name right, Ahmed. I mean, if I didn't, like, just comment here, just like say something, and then I'll know which account it is. But it should be there for you. Okay, cool. Hello, can you help with my differential geo? Yeah, maybe. Send it. If I can't do it, someone in my stream can, such as the awesome e to the 2i pi. Let me shout him out. Sorry, I forgot to shout you out, Zach. E to the 2i pi, yeah. Zach did another one of our questions from another student that we had yesterday. He did the differential equations one. I'll have to link Zach's VOD for that. That was fun to watch, Zach. I was watching that while I was at the gym. I was watching you. We were both struggling in different ways.
Well, I wanna. Can you link the
DiffyQ one? Yeah. It's this one right here. Here, I'll tag you in it. It was this one. I tagged him, but here.
Oh, okay.
Yeah, it was a little bit of a struggle, this one. I think because they were like trying to guess solutions or something. Yeah.
Oh, okay.
Yeah. Some of these people, these math warriors, these YouTube math warriors, like drop me questions that look innocuous, but then they end up being like obnoxious. So everyone got a sub. Road to 10K, so close. Thank you, Steven. Yeah, we picked up 300 subs last night, so I think we'll hit 10K really soon. All right, but yes, do go like, subscribe. It helps out the algorithm, and that way more students see this stream instead of feet pics and thirst traps and whatever. Trying to flood the doom scrolling with math zoom scrolling.
Just one comment. There's a method called variation of parameters.
Yes,
and
I forget if Zach did because I was gonna say also like integrating factors. They also tried Laplace transforms, I think.
Yeah, Laplace transform for a multiplication functions is difficult, so you can't do Laplace transform with that one. And the variation parameters is like the easiest one, but then you might end up with a disgusting. Yeah,
I think they ended up with like gamma functions or something. So they were just like, oh fuck yeah. Okay, cool. All right, let's see this one. In the figure, AC equals CD. Okay, so this equals this. That's beautiful. The measure of angle EBC is equal to X. Sorry, is equal to EBC. EBC. All right, this is 45 degrees. It's actually kind of fun. That's the general method. Also Laplace transforms. Yeah, I feel like all diffie-q is like just brute forcing things that look like it'll work and then seeing which one actually works. And this is 104. And then what is the angle X? Oh, that's cool. Well, because they told me that AC was equal to CD, that instantly tells me that this angle equals this angle, right? Here, let me mark it. This angle equals this angle. Great. Oh, and since I know this one's 104, okay, now we're already done, right?
Bing bang.
Because 104 plus 2x has to equal 180, right, for the whole triangle. So x is equal to 38. Cool. So now I know this is 38. I know this is 38. Oh, I see what's going to happen here. It's actually pretty cool. Or maybe you can use the 104. Well, here's what I'm going to do here. I also know, right, that this makes a triangle. Yeah? And I already know that this is 38 and this is 45, so now I can figure out this, and then we're done. Again, there are probably multiple ways to do this question. I'm just going to show you the way I would do it. Yeah, so then 45 plus 38 plus whatever, call it y, equals 180. So is that 83 plus y equals 180. So y equals to 97. That's this. 104 plus that angle is supplementary to 180. Yes. Okay. And then this is the last one here, where we just say like x plus 97 equals 180. That's literally what this shit is. So you get that x is equal to 83. Look good? Fembox, you say yes? I think it looks okay. Cool. All right, we're gonna count it.
Bing, bing, bang.
That was pretty easy. Fun question, though. Thank you. Whose was this? Spicy Nuggies. 46 plus... Wait, why did we get 46? Where's 46 from? 40. It was 45. Sorry, this is a 5. I apologize. I know they all look weird. I need to work on my handwriting. Here we go. That's a 5. No, good call, Ricardo. Thank you for like calling it out. Yeah, there you go. Is that better? All right, let me save this as Sir Nuggies. Uh-oh, I was AFK. The solutions manual was AFK. Oh no, dude. Do I know Diffie Q? I do. And if I don't know, I have other people in my chat, in my Discord, in my stage right now that do know Diffie Q. So submit it. We'll try it. Alright, so that was nuggies. Good job, spicy chicken nuggies. I like kind of the easier geometry ones. It's like a nice relaxing walk. Nuggies. I can definitely do 12th grade energy work physics, yeah. My PhD's in physics, so I love physics. I don't get enough physics questions, honestly. Much to Jeff's dismay. Ooh, okay, this is good. DM Scrader's asking about, this looks like factoring. I'm going to show you the way I do this, by the way, which is not conventional, but I think it's a cooler way to do these. I get too many. Can I do group theory? Personally, I cannot. However, Ben, please submit the screenshot regardless to that website, and it'll get sent to our Discord, and then I will forward it to one of the other awesome math streamers I know that does do group theory, and they can help you. But get it in the pipeline at least. I saw a TikTok today that was talking about a math teacher on here. Pretty cool. Nice. Probably Ramton. Ramton, do you know group theory?
Depends on the level of the group theory.
See? Exactly. So, Ben, you have to submit it for us to determine whether it is a level that we could do.
Does it go to web help screenshots?
No, it goes... so if you go to the website... And here, let me explain to everyone who's watching us right now. If you go to actualofficehours.com, this is the website where you drag in a screenshot and then just put your name, whatever, and hit upload. And then if you want to see all the questions that are in the queue so far, you just click live queue. And then if you click on any of these usernames, it'll pop out their question.
Oh, okay.
Yeah.
Called
actualofficehours.com. Yeah. So I don't know if Ben has submitted his yet, but Ben, when you submit it, make sure you use the same username so that we know who you are, and then someone else can look at it. Oh, nice. An educational side. Oh, Fem, send me. Can you send me the? Can you send me the ad? I always love to see what other people are doing for advertisements, especially in like the education sphere. Thank you, Ben. Yeah, submit it. Submit it. Ramton will take a look at it. On tour. So here's the other thing, Zach. I think we can apply for the STEM channel on TikTok. There's a separate STEM category, which I've thought about maybe like going into. All right, but let me do this one for DMs. So you're right. This is kind of an issue because you can't really factor this nicely. If there's a number in front of this, you have to do it a little bit more. You have to do a little bit more work. It's a little bit more difficult, but I'll show you. It's not too bad. So what I do is I take these two numbers, I multiply them together, and so that gets me -20. And then I want to figure out what two numbers multiply to -20 but add up to -8. Okay. And for those, I know that, okay, what is that going to be? 2 and -10. So notice how these multiply to -20, but 2 plus -10 adds to -8, okay? So these are our factors. Nice. Yeah. Nice. Thanks, Ricardo. Yeah. Having a recommendation from you guys is the best recommendation I can have. All right, so what I'm going to do now, you uploaded it, Ben? Sweet. Yeah, if it told you it uploaded and it gave you a Q number, then it's there. So I'm going to take these two numbers here. Do you see it, Ramton?
Oh, this is the group theory one.
Yeah.
Yeah, I'll have I need to refresh it.
All right. He's going to take a look at it. Okay. For DMs, so when you do this, once you figure out the two numbers, again, that multiply to this, which was these two multiplied, and also adds up to -8, you're going to put those on the diagonal with an X attached to them in what I call like a Punnett square. This kind of comes back to biology. Then I'm going to put this and this on the other two diagonals. So I'm going to put this one up here. We're going to say -4x squared. And then I'm going to put this one, the +5, that's going to come down here. Now your job is to try to factor out the biggest thing you can from any row or column. You can pick whatever you want. I'm going to pick this one and think, okay, what is this method called? I don't know. Call it the gold method. It just fucking works, and like I love it. I don't know if there's a name for it. But the biggest thing I can try to pull out of this, well, the biggest power of x I can pull out is a single x to the 1, right? I can't pull an x squared out of this. And good, yes, I can also pull out a -2. Very, very correct, right? Because 4 won't go into 10, but 2 will go into -4, and 2 will go into -10. Gold's rule, yeah, we'll call it Gold's rule. Okay, once you have that done, okay, now your job is to figure out what's here. And that's kind of like, you're doing like kind of reverse multiplication, because you're saying this times what gets me -4x squared. And that ends up being 2x, right? So 2x times -2x gets me -4x squared. Great. And then you move to like this corner. So -2x times what gets me -10x. That would be 5. Random user says, hey guys, I want to say thanks again. I'm getting my physics and math test back next week, but you guys have been there during my late night study sessions. It meant a lot. Awesome, dude. Yeah, thank you. You're very welcome, random user. Yeah, okay, he gets it. Okay, here. So I'll just quickly do the rest of it. So, and then here to here, right? 2x times what gets me 2x? That's 1. So then we're done. Because then these are your factors. So then you have 2x plus 5. -2x plus 1. Gold invents division. Yes, I did. Yes, and I'm calling it my rule. Was that the quadratic equation? It's a quadratic function, or a quadratic expression, technically, and we are factoring it. It's just, that's my way of factoring it when this thing isn't 1. Because it, like, kind of sucks. Yeah, but good question, DMs, dude. That's fun. JC, do you remember seeing the PubMed thing where someone thought they invented, like, integration? It's like a medical journal, and someone, and it got published. I think it was peer reviewed, and some med student thought they invented integration. Yeah, well, a lot of times, Ben, they want you to factor it because that's the best way for you to I don't know, find zeros and all that shit or something. So yeah, you're right that you can solve it with the quadratic equation easier, but a lot of times schools just want you to factor. All right, cool. DM Scratar. Yeah, do you know what I'm talking about? It's hilarious. Yeah, it's some medical researcher thought they invented integration. Yeah, it was the trapezoid rule, exactly. Yeah. They're like, I came up with this new method. I'm like, bro, it's a Riemann sum, dude. What? Oh man. This week has been the age of the Punnett squares for me. Are you also doing biology? All right. DMs, greater. Wait, are your DMs in my thing, right? DMs. There you go, DMs. Sick. All right, let's do the next one.
I love this next question.
Yeah, you might have to help me with this one. Clickbait's always asking me really fun physics ones that kind of hurt me, but they're fun. I was able to do clickbaits yesterday. So here, maybe you have to help me with this one, Rampton. Verify that two particles can be written in terms of, is that the center of mass and relative positions, as R1 is R over M2 R over M, and R2 is R minus M1 R over M. Hence, confirm that the total kinetic energy of the two particles can be expressed as that, where mu denotes the reduced... Yeah, I have no clue what this is. Do you want to do this one?
Yeah. Do I need permission to the...
Yeah, here. Did you log in? Just log in. I'll grant you presenter.
Where do I log in?
It's the... Here, I'll let me DM you the link real quick.
Okay, thank you.
There it is. And then... I forget what the permissions are. I think it's just Okay, good. Oh, you're in. All right, sweet. Okay, here you go.
Yeah.
Okay, now you have presenter privileges, so you can draw and write whatever.
Okay.
Rampton is an applied math super guide, so you can probably do some of the higher level physics that I forget how to do.
Okay. Am I doing things correctly right now?
I saw you somewhere.
1 sec.
You were drawing for a second, right here.
Okay. Yeah. Okay. All right. Yeah. So I'm not muted. Okay.
You're good. I can hear you, and everyone else on the stream can hear you too, because it's going through all my audio.
Okay. Nice. I'm gonna say. All right, I'm gonna connect my pad. 1 second.
Oh, nice. Okay, he's got a tablet as well. Is
Yeah.
Rampton the goat or something? He's one of the goats. Someone says you can do a
Well,
center of mass frame.
Yeah, you could do it, but you can also just do it in terms of writing the explicit. The total kinetic energy is the kinetic energy of the first object plus the second. For some reason my tab is not right. And then, so the total T is 1/2 M1 R1 dot squared, which is technically, this is R1 inner product with R1 dot. And then the same thing with 1/2 M2 and then R2 derivative of R2 dotted with R2.
Are they both derivatives? It's derivative of R2 times derivative dotted with derivative of R2.
It's
Okay,
like the V squared, right?
That's a magnitude.
Exactly. Yeah. So then the R1 in here, R1 dot, would be R dot plus. I don't know what, for some reason it doesn't pick up on. Okay, M2 R dot. So this R, I believe, is the total separation between the
between the two particles.
Between the two particles. Yeah, I think if I had a picture of this, it would be easier. But when you have like two particles that have a common center of mass that they are rotating about, this is like the oval shape, and then I believe that this would be R1 and this is R2.
Okay.
So you can always take the center of mass to be 0. And you know that M1 R1 plus M2 R2 needs to be like 0.
Okay, for the momentum, because the momentum of the whole system has to be 0. Okay.
This is the center of mass.
Center of mass, right? Yeah, exactly.
Yeah, center of mass is 0 at the center of mass, and then you write R1 and R2, and then you technically write this whole thing in terms of R.
So what is big R again? Sorry, what is big R?
Big R. I wish the problem told us what big R and small r in here.
Yeah.
Because
Or maybe there's supposed to be like a figure.
Yeah, I like forgot which R is what. That's the thing. But regardless, we don't need to know what they are, because once you figure this out, then you're good to go.
Okay.
Okay, so then you have R1 dot, which is the velocity of this is V1.
Yeah.
It's just derivative of that is equals to this. And then R1 dotted with R1.
Ooh,
R1
there's gonna be some cross products, right?
Yes. But so this one would be, so R1 dot squared.
Yeah.
Plus M2 squared R squared over M squared. And then it's going to be the cross terms.
Yes.
Right, so plus 2
big R dot dotted with little r dot and then like an M2M.
Yeah, dotted with little r dot M2 over big M.
Gotcha.
And then if you do the same thing for R2 dotted with R2, because the terms are very similar, so I feel like.
Oh, interesting. R1 is in terms of M2, but R2 is in terms of M1. Why did they do that? What?
Yeah, because again, it's kind of like it ends up being in terms of the center of mass is 0.
Okay.
And this is essentially given the fact that R2 is measured from where the center of mass is. So
I see.
R1.
I see.
Yeah,
I see. Okay.
So that's
okay.
why,
Gotcha.
like, the center of mass, if you are sitting at center of mass, the sum of all of the M1 R1, or sorry, the sum of MI RI this is equals to your center of mass, right? But then if you are at center of mass, this is just 0.
Okay.
Sorry, divided by, oh yeah, this is divided by total M. That's where you get that. So big M is the total M, which is M1 plus M2.
Got you. Okay, okay. I see, the reduced mass.
So yeah, this is like divided by M1 plus M2.
Got you. Okay, center mass. Yeah, yeah, yeah.
And then those, yeah. So then R2 dotted with R2 is going to give us R dot plus M1 R dot, sorry, it's the square, M1 squared, R1 squared over M squared minus 2 M1 over M. Sorry, I feel like my handwriting is
You're okay.
So
you look fine. You look fine. I can see it.
And then, yeah, minus 2. And then R dotted with M. Oh, sorry,
big R.
Dotted with big R, yeah.
Yeah.
Okay, now we'll just have to add these two.
Okay.
Times by 1/2 of the M1. Okay, so the total kinetic energy would be
is T1 plus T2. Got you. Okay.
Yeah. M1 times this R1 squared. So I'm going to keep these terms kind of together and then the cross terms together because they're going to cancel out. So it's going to be 1/2 M1 times this entire expression. So it's going to be 1/2 M1 big R dot squared plus M1 M2 squared.
Okay.
I'm going to keep the 1/2 in. Sorry, because it's then not going to look so great. Divided by M squared R dot squared. And then plus. So here, instead of writing it out, let's see why this is. So we have an M2 here.
Yeah.
So these two terms are exactly the same, right?
So they're gonna. This one has a plus on it, and this one has a minus.
Yeah, except that this is an M1 and this is an M2.
Got you.
Right? But the M2 is in the term for R1. So
yes.
when we multiply this later by 1/2 M1, this becomes the two R's.
And then M2 M1
over M, and then this one is the same thing, but then this one gets an M2,
and then this one gets an M1.
This one gets an M1.
So then they just cancel. Got you.
Yeah, and then the other one you get 1/2 M2 R2 squared.
Yes. Oh, I see where the mu's coming out right away. Oh, this is fucking cool.
Plus, yeah, M1 M2. Oh, sorry.
Yeah.
Yeah, M1 squared M2.
Yeah.
Divided by big M squared. And then R squared.
Yeah.
And then from here, I'm going to factor out the 1/2 big R squared from these.
Yeah.
I have M1 plus M2.
Yeah. And
comparing it to this, you see big M is the total mass.
Right, so yeah, this big M here is equal to M1 plus M2. Perfect, nice, I like that.
So that's our first term that we got.
Yeah, that's this one.
And then our second term is going to be 1/2
let's see what happens. Yeah.
Squared. And then this would be M2 squared, M1, M2. I'm factoring in M1, M2 from this. So
gotcha.
I'll get
because you have one of these at least.
Plus M1.
M1, yeah.
So this ends up being, this is explicitly just M.
Good.
Right? This is M. So this cancels out with one of the factors of this.
Yeah.
So you have this second term is 1/2 R dot squared.
Yeah.
M1, M2 over M1 plus M2.
Which is big M, right? That's just, this is what we wanted. We wanted this to be.
This is the reduced mass.
This is the reduced mass. Nice. Yeah.
Yeah, that's mu. Right here.
Nice. Yeah, that's exactly what we wanted then, yeah?
Yep. And then this
Sick.
is it.
Wow, nice job, Ramton. Get up for Ramton. That was a great job. Good question there.
I remember this was one of my favorite problems that was on my final exam and then you can do this problem with like Coriolis force also.
Okay.
And you get so many
like cross terms and stuff.
Yeah, I remember this was my second year exam and it was like 4 pages long if you take into account cross terms.
No, dude. What? That's just mean. Dub solution. Wow, you got a lot of emotes in the chat. Yeah, nice. Thanks, Ramton.
Thank you.
Yeah, no, thank you. Yeah, see, you get back into it. You're good, dude. Imagine not being able to bring paper for all this. Yeah, usually you do get to bring paper to exams.
Oh, they give us a booklet. So we had like one sheet that's just the exam. And then the other one was just an empty like 20-page booklet.
Yeah, like a blue book. They're called like blue books sometimes, right?
Might be the American thing.
Yeah,
they just call it booklet.
For us, dude, there are these here blue book exams. Here, one sec. Yeah, stuff like this. This is what you're allowed to bring in.
Okay.
Yeah.
It looks very much like that, but it's not blue. So it makes sense why it's called blue book.
Yeah. I don't know if they still do these, but back in my day, this was annoying. Like every time you had a test, you had to go like buy one of these at like a convenience store before going to class.
Wait, you had to bring it yourself?
Yeah. These weren't provided. You had to buy these. And if you didn't have one, you were like shit out of luck. They were like, oh, you just can't take the exam.
Okay.
Like you're fucked.
Okay. No, for us, they actually gave us the paper.
Yeah. That's good. Husei says, can you look at my Bessel function homework? You can submit it. Again, submit anything. If I can't do it, someone else can probably do it on my stream. And even if they can't do it, we have another whole other family of awesome math and science streamers that can probably help you out. So please just submit it. We'll take a look at it for sure. Bessel functions, exactly. Go on, Ranton.
I think I can do the Bessel functions one, but I took a look at the group theory one.
Yeah.
And I think it's a little outside of my scope, but whoever does it, please tag me in it because I want to see the proof for that.
Okay. Yeah. So at the end of this stream, I always post everything that we didn't do. It'll go into the forum anyways, and then I'll tag like Math Genius or Math. I think I changed it back to Math Gods. I liked Math Gods, and so then it's like a forum. It's like a thread that people can like contribute on. Yeah. See, Mathematic Fanatic says maybe I can do group theory. Awesome. Yeah. Would be happy for you to try, dude. Let's see. Charles needs help. Charles, which one Charles, you sent me like 3 different things, Charles. You gotta send me just one. Let me do this one for you, Charles. I will do this one. This one's not bad. Dun, dun. Also, if anybody else wants to see the problems that are being submitted, they're on the channel there. They're on the website, actualofficehours.com. Go to the live queue. Click on a bunch of things. I think Ben Wise is the one that threw up the group theory question. So if anyone else throws another one up there, like you'll see it. I almost did a problem on here, but I went to bed instead. Sleep is for the weak, dude. What? Okay, let me try this one out. This one was for Charles, dude. You want to graph this. Okay, well, this kind of sucks to graph as it is. So I'm going to put this into a fun form that we call vertex form.
Good job.
The way we do that is I always try to pull out something on whatever's on the front of this x squared. I want to factor it out. So I'm going to say -2 times, and this is going to be x squared minus 8x plus 24. Or plus 12, sorry. There we go. Right? -2x squared plus 16x. Yep. Now, I'm going to try to factor this, and this should hopefully be nicer. And I think it is, right? So, like, what adds up to 12 but multiplies to -8? We know that's going to be -2 and -6, right? So, watch. -2 times -6 gets me positive 12. -2 plus -6 gets me -8. And so now I can factor that out into x minus 2. Oh, actually, we want to complete the square on this one. My bad. Take that back. Rewind. Okay. I'm going to... Yeah, whatever. I'll leave this here. This is okay. Sorry, I forgot. We're not factoring. We did factoring on the last one. This one, what we want to do is we want to do... I mean, you could still factor it, and then you get the zeros. And then the midpoint's nice, but let me show you the vertex form just while we're at it. Take this. Math makes so hard math makes so hard or math is so hard. I mean, math can be hard sometimes. Divide by 2 and then square it. That's what I want to do. So 8 divided by 2, which is equals to 4, and then we square it. So then we're going to add 4 squared and we're going to subtract 4 squared. This is effectively the same thing as adding 0, so it's okay. You can always add 0 to stuff. That's totally fine. All right, now what I have is -2. This thing right here is a perfect square trinomial. So this ends up being x minus 4 squared. So whatever this is, plus or minus this, ends up becoming this. But then you still have this. You still have -4 squared plus 12. So then your last little piece of work you need to do is just multiply this through and make sure everything's simplified. So -4 squared is going to be -16. -16 plus 12 is -4. And then we're going to multiply -2 through. So I'm going to get 8, -2 x minus 4 squared. And then this is your function. Nice. Cool. I think that looks pretty good so far. -16 plus 12 is -4. Yeah. So let me know so far, Charles, if you're not getting this. But the nice thing about this is very easy to plot because I know this is a vertex. This is a parabola pointing down that has a vertex at h comma k, which is going to be 4 comma 8. So now my graph here, I can go find 4 comma 8. So 1, 2, 3, 4, and then I can go up 8, up to 5, 6, 7, 8. And then I know it points down. Your teacher may want you to figure out, I guess, like, what the zeros are. Which, let's see, what was it again? It was 8, so it was like, I think it was +2 and +6. Yeah. Just from what I remember when we factored. I think it was this. And that makes sense, right? 1, 2, 1, 2. Yeah, okay. Last thing, make sure, well, second to last thing, you do a dashed line on this if this was just less than, but because it's less than or equal to, you end up doing a solid line. I'm going to watch this next week. I should probably rewatch this. Yeah. All the VODs are recorded. Everything we do here is recorded. So if you ever want to, like, get help with it again, you can. All right, that's done. Now you need to figure out where to shade things, okay? So to shade, you pick a point and test. I like to pick 0, 0. That's a really fun point to go check, and it makes equations easy and stuff, right? Okay, so let's just check 0 here, for instance. So if I have y, which will now be 0, is less than or equal to -2 times 0 squared plus 16 times 0 minus 24. This goes away. This goes away. You get 0 is less than or equal to -24. Is that true? It's not. So if it's not true, it means we do not graph or shade in this region. Instead, we do the other region, which is here. And then you're done, Charles. Cool? Not too bad.
Another way I like to sometimes think about it is like the equation. It tells you where is y less than or equal the right-hand side, right?
Good.
So think about where is below the graph almost.
Yes.
And then it would be.
So yeah, if it was greater than that, right? It would be all the y values above that, which would be the other upside part of it. Yeah.
Or outside, I guess. Yeah.
Yeah. No, I agree. All right. Good question, Charles. I think which one did I do for you? That was your. I think I did your third one. Is what I did here. This was your third one. Let me mark your third one done. What's up, Abin? Good to see you from yesterday. Abin was on last night. I remember you. But there you go, Charles. Questions in there. Oh, is my chat going through? Are you guys chomping on the group theory question, or what was it? I think someone asked like a algebraic something question. Which one was that, by the way? I can throw that into a forum if you guys want to like write things already on it. You can do stuff in the chat too. I don't care. But let me see.
If it's Ben is the one who put the group theory.
Okay, so this was the group theory question.
Number 9.
Let me see. Okay. I see. Okay, here. Just because I know Ben, I'm not gonna, because I think your question's like number 11 on the queue, and I'm not gonna get to it. And I don't know that I'll be able to solve this. I'm gonna put this in our form right now, so that if anyone wants to comment on it and leave some stuff, they can. So that was number 9. So let me put that in. 9 for Ben. Post 9. Delete 9. And then we already got Charles's on 3, so let me delete 3. And then post 1. And then post 2. And then delete 1. Delete 2. Okay, Penn Center did an entire class on this a few months ago. Yeah, didn't he? He did have a whole thing on it. The classes were always fun. I think I was teaching at UCLA at the time. Nice. So yeah, Ben, your question's right here. Yeah. Oh wait, let me show you. Sorry. So Ben, yours is right here. If people want to comment on that one, and then let me drop Charles's solution in for the last one real quick.
Wait, Penn Center did a whole course on group theory?
I think he did. Did he not? I think he did a whole thing on group theory. There was also a real analysis course. Yeah, I think they recorded the VOD somewhere.
Oh, okay, that would be nice.
Or if you go into his Discord, I think maybe Penn still has it up. He had like a whole channel for it. Yeah.
Is it The Elements Penn Center?
Yes, The Elements is him. Yeah, for sure.
Okay, yeah.
W Streamer, thanks, BK. Okay. Was that the one you guys were talking about in my chat, or was it somebody else's? That someone tell me if it was another one. It says prove it. Well, this is in a different language. I don't know what that language is. I did a Group Theory 1 course, and I'm doing Group Theory 2 right now. Group Theory 2 is so hard. I'm sorry for you.
Oh, no.
I want to learn more group theory.
Yeah.
Yeah, I'm like trying to study Lie algebra right now by myself.
Okay.
For physics, so maybe I'll do something on that later.
That could be cool.
There's a lot of other stuff that I want to cover, maybe in the future. Some videos.
Always learning. That's what I say. Like, dude, I learn something every day, honestly. Let me delete number 1. Okay, Logan, you're next. Logan, let me help yours out. Sorry, Logan. Go through all these. Ooh, okay, good. I love this. This is physics. Bingo, bingo, mango. Let's do some physics. Dude, Waldo. I'm about to obliterate the group theory question. Yes, Waldo. Comment in that question. Whose was it? Sorry, by the way. Was this one? And then is your name also Waldo? Yeah, dude, Waldo here. I'll give you the math god role. Yeah, you already have it, dude, Waldo. Yeah, you got it. I give it to you. Benz. Yeah, it's Benz. Yeah, I put Benz in there. Okay, let's do this one though. This is physics. I can do this. This is pretty easy. Yes, I did. You have the role, dude, Waldo. I'm pretty sure you're a math god in my Discord. I feel like a lot of teens here just don't feel like talking. I talk because I'm young and stuff. Yeah, talk as much as you want. It's the internet. You're all anonymous anyways. Like, what? What fears do you guys have? Spout off, dude. All right, a 274 Newton uniform ladder, 11 meters long, rests along a smooth vertical wall. The coefficient of static friction between the ladder and the floor is that. What minimum angle can the ladder make with the floor before it slips? Oh, interesting. So the wall has no friction. That's what they mean when they mean like smooth wall. I agree. You mean calculate the mass first? Oh, no, DMs. That's because that guy last night just kept. He wasn't yapping on my. He was yapping in my live stream about how beautiful I was or some shit. And I was like, it's like, bro, can you stop, please? Yeah. No, you can yap all you want. Just don't be yapping distractingly, I guess. All right. This here. Let's draw the ladder. Yeah. Yeah. No, it was weird. It's okay. Like we get trolls every once in a while, especially on YouTube. I had 14,000 views that evening. It was crazy. I'm gonna have at least one weirdo who's like trying to like sexually harass me during my stream. Kind of take it as a compliment though. And then this coefficient, cool, which I think we say mu s is equal to 0.4. What's the minimum angle it can make with the floor before it slips? Ooh, that's cool. All right. And then there's no friction here. Exactly, Aben. I agree with that. Yes. So we can always reduce this ladder to a point mass, which is located at the midpoint of the ladder. And so that's going to be located at a distance 5.5 meters up. And then I don't like this. Well, whatever. We can leave the 274, right? And so that's going to have a force equal to 274 newtons. Okay, great. Now, there is also going to be a force on the ladder from the wall, right? And so this is like force wall on ladder, right? Because this thing is resting against this. No, you can submit 2 screenshots. I'm just tell me which one to go through first. Okay. And then this will also have a normal force pointing up. So we'll say force of the ground. Floor here. Force of the floor, which is really the normal force on this. And then if this thing is not going to slip, then it also needs to have a force of friction. Right? That is pushing it to the right. Okay, cool. So I always like to write out like sum of forces just blindly, just see what happens. Okay, so sum of forces in the x direction. You have the force of friction minus the force of the wall on the ladder. Let's say WL. Sum of forces in the y direction. You have the force of the floor minus 274. Cool. I know that force of friction, this is equal to mu k Fn. But in this case, Fn is the normal force from the floor. So this is mu k F floor. So I can just replace this with, mu s F floor. We assume it's not moving. Okay, cool. All right. And then I know this needs to be equal to 0, and I need to know this equals to be equal to 0. Right. So I have, cool. I have two equations and 2 unknowns, right? So I think I can just solve. I can solve for the force on the floor. That's cool. And then I think we can eventually find the angle because it's probably going to do something with the torque. Yeah. All right. Yeah, okay. So force floor is equal to F WL wall on ladder divided by mu s. And then you can plug that into here. So you get F WL over mu s is equal to 274. Okay, cool. Where's my calculator? Dynamics cooked me. I like dynamics better, honestly. Okay, so 274. Did they give me a mu s? Yeah, 274 times 0.4. It's like related rates. Oh, maybe. Okay, so that tells me that FWL is equal to 109.6 newtons. And then from this, if you will find the force on the floor. Oh, wait, the force on the floor is just 274 then. Yeah, what? Duh. Oh, this is so... Oh, whoa, I'm really dumb. Sorry. We could have just solved for force floor right away. Okay, cool. That, and then the force of the floor is equal to... I don't even know why I did that, but whatever. Okay, cool. 274 newtons. We needed this one as well. Great. Okay. Now I need to figure out the angle. Okay. The angle needs to do with the torques. Okay. So I'm going to choose a rotation point, which this I'm going to choose as like my rotation point. So now all I need to do is calculate the torque from this, trying to pull it down. And then the torque from this, trying to like push it in the counterclockwise direction. I don't care about any of the forces here because their radius from the pivot is 0. So that's why whenever I always say this in my physics classes I teach, if you want to pick a rotation point, pick somewhere where you can start eliminating the most amount of forces. If you pick your rotation point here, you knock both of these out, which is really nice. If you pick this as your rotation, you only knock out one force, and then you got to deal with all 3 of these, right? So pick your rotation point where the most amount of forces are originating from, and then you don't have to worry about them. Yeah. Proof time overlaps with itself. I don't know what the fuck that means, dude. What? Okay. All right, so let's do sum of torques. So, sum of torques, that's going to be equal to, let's do this one first. Okay. So this is going to be 274 newtons. And then if I want to know the distance, right? So this is the other cool thing about torque. So you can either figure out the amount of force which is perpendicular to the radius, or you can find the amount of radius which is perpendicular to the force. Because torque is just always R cross F. And what this means in simple terms, this is either R perp times F, or this is R times F perp. So, actual education, how do I stop gooning instead of doing my homework? Do your fucking homework, dude. Gooning's not gonna get you anywhere. Doing your homework will allow you to stop gooning, because then you will have money and you'll be able to take girls on dates, and then you won't have to goon anymore. Is that okay? Is that a good way for you to think about it? Okay. So this is the force. I want the perpendicular distance to that. That's this, okay? This is a triangle, right? If this is theta, and then I know this distance is 5.5, then I can get this, right? Because this is the adjacent. This is the hypotenuse, right? So then cosine of theta is equal to, we can call this like R perp over the hypotenuse, which is 5.5. So then this is going to be 274 times 5.5 cosine theta. All right. And that is positive torque. Wait, no, sorry, that's negative torque, because that points clockwise. Zoomers be on something else. I tell you what, yeah, it's okay. They'll figure it out. Okay, and then this one. This is really cool, too. So here, this is going to be positive torque because it's counterclockwise. So that's going to be FWL, which we know is 109.6. And then again, if I'm choosing the force to be left-right, then the distance I care about, my R, has to be up-down. That's what R perp is. R perp is now the up-down distance from the origin to where the force is, because the force is left-right. And that ends up being this. And what is this as part of the triangle? Oh, that's just 11 sine of theta. So this is like super nice. Okay? And all this shit equals 0. Because all the torques add up to 0. Okay. Alright, so now let's rearrange that. Right? So I have 274 times 5.5 cosine of theta is equal to 109.6 times 11 times the sine of theta. So this is cosine theta, sine theta. Watch what we're going to do here. This is some cool algebra tricks. This is why it's good to remember trig, especially in physics, especially in mechanics. I'm going to move the cosine over here. This is going to be sine over cosine. I'm going to move this shit over here. And now I have sine over cosine is equal to this. This is tangent. Ultimate nerd activity? No, bro. I played Warhammer 40k, dude. That's the ultimate nerd activity.
That's dope.
What are you talking about, dude? Math is not the ultimate. You can go further. Okay, tangent of theta is equal to this huge mess. I'm going to get a calculator out. What topic is this? This is physics. Probably physics, AP Physics 1, I would suppose. Yeah, I think it's AP Physics 1.
Wait, is AP not B and C anymore?
No, well, there's 2 of them. So AP Physics 1 is algebra based, and then AP Physics C is calculus based.
Oh, okay.
Yeah, we took C, but there's a new one called AP Physics 1. It's not new, it's been out for a while, but it's mainly for like, it's kind of like the life sciences version of physics in college, right?
I see.
Yeah. All right, take the inverse tangent on both sides, because that's gonna rip my tangent out. Good, this goes away. And so I get theta is equal to the arc tangent of 1.25. Let's see what that is. Should be something nice. 51.34 degrees. Nice. And you're done.
That's dope.
Why not an Nspire CX Cast 2? Because most students still use a TI-84, or they use some form of it, and I like to show what buttons you press to do fancy shit on it. I agree, it's a cool calculator, yeah, but most kids don't have one, and it wasn't allowed. It was the only allowed calculator on standardized tests for a while. BK says, managing your own homebrew world as a D&D campaign for the past 5 years, that's some nerd shit. Correct. Dungeons & Dragons is dope, though, dude. What? That's fun. I've had some fun times with Dungeons & Dragons. Good job, Logan, by the way. We'll put that question in the queue for you. My professors don't allow that calculator. I'm sure, yeah, some of them don't, because it is very powerful. You can do, you know, matrix stuff instead of systems of equations. It's great. If you get to higher level classes, you don't even get a calculator. Everything is symbolic. Like, it's all variables. Just imagine, like, all you can do is, like, deal with, like, letters. Good question, Logan, by the way. Okay, we're up to 126 on YouTube. What's up, YouTube? Good to see all you guys.
My man.
Again, if you're just joining us from either, TikTok, YouTube, Twitch, Discord, whatever, the website is, where's the website? Do I not have it up? Yeah, here it is. Website is actualofficehours.com. You can type your username in, drop in a screenshot, drop in whatever you need help with. We'll tell you whether we can do it or not. If we can't, I have other people that can help out. So I know a lot of people ask, like, can you do this? Can you do this? Try me. Just do it. And I can do most math and science, middle school through like early college. And then if it's harder, we have Ramton in the voice channel, or I also have other math people that stream that do higher level math stuff. Someone's already going to town on Ben's question. What is this? Dude, Waldo? Yeah, nice, dude. He's already going through it. Okay, cool. I love that. That's sick. All right.
I saw there's a partial differential equation question. That one's pretty.
Yeah, I might pass that to someone because I don't know PDEs. I know Diffie-Q, I don't know PDEs, but yeah. So bless Waldo. Look, Waldo's already going through and answering this question, which I knew I could not do this question. Something about
yeah,
that.
I'm definitely gonna read that later for sure.
Yeah, exactly. It's like it's a little light reading for you guys, or not.
Nice.
Thanks for the follow. All right, let's get the next one. Next one is Droove. Oh, we got hinged rods, tension and compression. You engineering kids.
Disqualified.
God damn it. I hate engineering. Okay, also, I need the figure, apparently. Did you send me the figure as well, Droove?
Nice.
Oh, this is just a blank page. Oh, fuck. I need the figure. Oh, I think he sent it on.
It's there.
It's the third one. There it is. Got it. Well, wait. This is a different question. Wait. Was it there? Oh, it's on the side. It's on the side. Oh, I see it now. Got you, Droove. No, I see you. It's this one. Got you, bro. Ooh, look at this. This is fun. I'm gonna make it straight though. Okay, find the forces In the hinged rods, BC and AC, if AB is equal to 60 centimeters, okay, AB is 60. Okay, so this right here is 60, or we'll say like 0.6, right? AC is 1.2. Are we gonna do like some law of cosines here? I feel like we're going to. BC is 1.6. Hanging mass has a mass of 50 kilograms. Cool. So that tells me right away, right? We got, what was that? 490 newtons pulling down from here. And the mass of the rods can be neglected. C is a hinge. C is a hinge. Okay. Find the forces in the hinged rods. So what are they asking here? So you just want like the tension in this, or the forces on the rod? In the previous task, tangent theta is 1/2u. It doesn't depend on the length or the mass. Yes. Yeah, and I think we had that too, right? 1/2 mu. Yeah, 1/2 times 0.4 is 1/0.8. Yeah, you're right. That is right, Casey. Yeah, that's a cool simplification of it. Yeah. Lammy's theorem? Fuck is Lammy's theorem, dude? What? Okay. AC is in tension with a force of 1,000 newtons. AC is in tension with a force... Oh, wait. These are the answer choices. Oh. Oh, thank you, Lonesome's Crow. Yeah. Yeah, I hate that it's called moment and not torque. But yeah, that is a reason why. Forces are in proportion to the side lengths. Okay, cool. Stress and strain, don't do it. Okay. He says no. No. Okay, if this is pulling 490 down, do I know that like each one of these has to then contribute a force eventually that equals up to 490 in the up direction, right? Femvox says he thinks A and C are correct. Let's see why that is, maybe. I can probably get some angles, right? So let's get some angles. I think if I get like this angle and this angle and maybe this angle, like, or I just need two of the angles actually, but okay. Let's get angle A. So 1.6 squared is equal to 1.2 squared plus 0.6 squared minus 2 times 1.2 times 0.6 times the cosine of A. And then I can get B as well, and then we already know what C is. 1.2 squared is equal to 1.6 squared plus 0.6 squared minus 2. Angles are unnecessary, are messy, tricky to find. They're not. You think it's just a 6 to 12 to 6 to 16 ratio? Yeah, do it, man. Do the math courses. So why is it proportional to the length, Femvox? I was gonna get some angles. You don't want angles? A and C is correct. Well, here, Femvox, you want to explain why? This is some this is some engineering voodoo magic that I'm not familiar with. I was gonna figure out like what the angles are and then like what the force on the hinges is, because it's an equilibrium force triangle. Okay. But doesn't it have 490 newtons pointing down into my courses? Oh, I don't run courses, but some of the other people in our streams, in our friend streams, they run courses. Follow them on Twitch, Click Void, if you want. They're here. I'll post the list of them. Let me post it in the YouTube real quick. The three forces at... Oh, I see what you're saying. This is actually really cool. Yes. Okay, let me show what Fembox says. That's actually really cool. And then here, one sec. Let me get Click Void. Let me get you all the math streamers real quick for you. Jorgen, good to see you, dude. It says tension above, compression below. Right, okay. Okay, he's saying that, okay, in this case, are you talking about, like, this is a force, right? This is a force. Sorry, this must be a force. And then this must be a force. Right, from here. And then here. And then this is down. And then they all have to sum up to 0. Is that kind of what we're saying, Fembox? Yeah, okay, I kind of like this. This is cool. So then, if, for instance, I then take this force here, and I put it here. Well, this one needs to, like, go in the right way then. Exactly. This one is opposite, right? Yep. What streamer can teach the highest complexity of math? Probably Zach or Penn Center. They have PhDs in math. Penn Center is a professor at a math college, so. How did I get 490? The mass has the mass is 50 kilograms, so 50 times 9.8 is equal to 490. I'm pretty sure. That's just m times g, right? Okay. And then what you're saying is, I know that this one here is 490. And then the other forces is the same ratio of the sides, right? This is a similar triangle. So this to this is the same thing as this to this. Is that right? So 0.6 over 1.2 is equal to 490 over AC. Oh, they just rounded to 500. Okay, we can do that too. So, 0.6 AC, yeah, whatever, let's call it 500, is equal to 800. So then AC is equal to 3/2 of 800. So that's equal to 1200? But I don't think that was one of the choices. They got 1,000. Right? And then the other one would be 1.6 over 0.6. Wait. Oh, maybe I did this wrong. I did do this wrong, sorry. Wait. This was, yeah. Check that 0.6. Yeah, no, I did that wrong. Yeah, sorry. I did this wrong. Fuck. Sorry. This is this one, which is AC. 1.2 to 0.6. Is equal to 490 over AC, right? So then this is 2 is equal to 490 over AC. Wait, that's... Ooh, now I get less. I wanted 1,000 though. Wait, what am I doing wrong here? Oh, no. This is AC over 490. Sorry. Got it. Okay. 2 is equal to AC over 490. So then AC is equal to 980. Cool. I've never done this class, no. But I'm using properties of geometry here, which is that if you look at, and this is physics at the end of the day. It's an engineering question, but you can apply physics concepts to it, which if you look at the forces at point C here, you have tension from these two rods, which is then pushing in this way and this way, or I guess compression maybe. And then you have the force of gravity from this thing pulling down. And so then if you put these together, like I did here, this makes a triangle, which is similar to this triangle. I will always accept help, Cotty. Yeah, if you want to help out. If I'm doing it the wrong way, please tell me. Because then for this, 1.6, you'll need other than geometry to resolve that. Maybe. What do you think I need to do? Pen Center. His name's Pen Center. Yes, I do chem. I don't think you need the angle of B. And then, what is this? 1.6 over 0.6 is equal to BC over 490. So what is that? That's 1.6 over 6. 16 over 10 divided by 6 over 10 times 10 over 6. Oh yeah, 16 over 6. What's that? 8 over 3 times 490. Oh, and look at this. Yeah. Now this is 4,000 over 3, which is equal to BC. And that was answer choice C, which you said was correct. Nice. Okay, cool. Cody says, you need the angle to calculate the tension applied with the length of the rod. I think I see what you're saying here. Because, okay, if this is pulling down, that's going to cause this to compress. Wait, why is one called compression and one's called tension, by the way? Sorry. What's the difference in these two? I just think of them as like ropes.
Compression is like it's being like pushed from both ends, and then tension is being like, stretched. Ah, okay. I think I get that. Because as that down force.
As this thing gets pulled down, right? This is going to stretch out, but this is going to push in.
Yeah.
Oh, so I have my forces kind of backwards then, right? So this one should have been in this direction. I see.
Yeah.
Uh-huh. Okay, but it still makes the same triangle.
No, the other way. The other way.
Wait. The rod below is squeezed, the top one is stretched, but the same triangle results. I see. But this is still down then, right? So
yeah. Oh yeah. Sorry, you're right. Yes.
This is compressed. This is stretched. But then I have a force coming down as well.
Yeah, and it kind of makes sense because if you follow the what's it called, the tip to tail rule, they all cancel out.
I see. So then, yeah, if I add them all together, oh, I see. You get the same triangle. Well, if it was to scale, but yeah. Oh, that's cool. Nice. So yeah, Cody, I don't think you need the angles. I think you just know it makes a triangle and that these are similar triangles. So I mean, this is something Fembox is in our Twitch chat, and he's kind of shown me it. Yes, and there you go. And Jorgen says, I took the -1 out of 1 force. Yeah, minus equals a plus. Yes, good. 2 wrongs make a right. Sorry, Mom. Anyways, all right. Cool question regardless. I'm glad I was able to get through an engineering question. Engineering stuff is always so weird to me. But that was Drew. Let's mark that as Drew. Good question, Drew. Does that make sense, Drew, to you, by the way? I agree with you, Cody. Like, I tried to start doing law of cosines to start finding out angles, but it has been something that Fembox has, like, brought to my attention multiple times with these questions, is that you just need to, like, make triangles. And then the force triangle needs to be equal to 0. 2 wrongs make a right. Sorry, Mom. No way you dissed your parents. Well, my mother's actually great. I have 5 sisters, so my poor mother somehow had to raise all 6 of us, so she gets a lot of credit for a lot of things. Alright, let's see.
I might hop out here. I tried doing the click void question.
Yeah.
He's the one who submitted the partial differential equation.
Okay.
And I don't know if he typed it out or not, but I tried it, and is it supposed to be 3u du dx? I wanted to ask if he's around.
Oh wait, I see. Here, let me pop. Here, I'll yeah, it's this one, I guess. Is this a partial differential equation? Is that what we're talking about? This one?
Yeah.
I'm gonna post that. I'll post that to the channel anyways.
Yeah, I was doing it, and then I think the fact that there's the 2 u's in that middle term, I was like, oh god, I guess this is not gonna be, because I was gonna use separation of variables.
This part right here.
Yeah, without the u, it's not, I wouldn't say like not easy, but it's a lot doable. But then with
the u, Zach says it's non-linear. It's non-linear.
Yeah, I don't even know how. Yeah, so if someone
click void, if you want to talk about that, click void. It's in our thread too. I put it in our Discord already, so it's gonna be this one right here. I'm gonna tag the math gods. Math gods away.
We should have put a semi-math god and then put me in that.
No, you're a math god too, dude.
I don't think
you're a math god.
Is on the same level as everybody else.
Your math is higher than my math, so you're a math god. Yeah. Fnatic says maybe there's some clever substitution that makes it linear. Maybe. I don't know. That's y'all's wheelhouse. But the Bessel function I solved in, yeah. Looks like a fun PDE. Well, if y'all want to go after it, also Psycode, yeah, if you join our Discord and you want to be a math god, just DM me.
Nice.
I will soon be making applications for math gods, but for now I'm just giving it to whoever I think is good at math. So.
All right, I'm gonna head out here, but
all right, good to see you, Rimpton. I appreciate it, dude. Thanks for helping with that question. That was dope.
Yeah, of course. Yeah, we'll chat on Friday then. I'll like
Friday. Message me like Thursday night or like Friday morning, and we'll figure out a time. Okay.
Yeah, sounds good.
All right, thanks, Rampton. Appreciate it.
All right, no worries. Have a good night.
Psycho says I'm not qualified to be a math god. Yeah, maybe I'll have to get the other math gods together to have them vote on like what they think the requirements should be to be a math god. Because I don't want to dilute the position. You're right. I am a physics genius. Yeah, I think I would give myself like physics genius. Sure. At least with up to like undergrad. When we start getting to graduate level stuff, I start like just don't want to do it. If you want to, Cotty, join our Discord, dog. There's a Discord. Actual Off House, if you go to that website down there, there's a link to join the Discord, and then you can also see the question that I just did right here with my my shoddy method. If you want to post a screenshot of your method, I'd love to see it, dude. Oh, the Bessel function? Which one is that, JC? Which one is it? Whose is it? What user is it? I don't even know what a Bessel function looks like. It says proof it. Okay, cool. Yeah, I will put that one in. So that's number 4. So there we go. All right, so I'm taking 4 off the queue. And that is now in our Discord. So if you want to go debate about it or try to figure it out, go for it, guys. This whole website is vibe coded. It is. I coded this on a plane flight to Chicago with ChatGPT. I did it about... I got the initial coding done in like 4 hours, and then I've had like a couple multi-hour sessions to like fix things. Like someone figured out how they could just spam the website with like Shrek pics. So I've had to like put like some patches in it because vibe coding doesn't take care of all the security risks, and it works mostly. But yeah, it's all vibe coded. Yeah, I mean, I understand how to code. I just fucking hate web coding.
Surprise, motherfucker.
So having ChatGPT just tell me what the PHP syntax is just saves my life. It's such a beautiful thing. Otherwise that thing would never get done because I would just get so because you can't debug web coding. There's no like compiler. There's no error on line 34. The website just doesn't load. It's the worst. I hate web coding. Oh, can't see the entire question on YouTube, by the way. Cuts off as do and starts at bank. Oh, really? It should look okay now. Yeah. Sorry, the YouTube is vertical, but here, okay, there we go. We'll do it here. A bank vault is opened by applying a force of 140 newtons perpendicular to the plane of the door, 1.2 meters from the hinges. Find the torque about an axis through its hinges. Nice. I think this is very nice, right? This is easy. So torque is again equal to R perp times F, or R times F perp. A little bit more to the right. You want to like there? All right, Hussein, JC he posted a solution to yours in the Discord if you want to check it out. Okay, so I mean, this is easy, right? Because they already tell us it's a perpendicular force. This is, yeah, thank you. I love softballs. They're so fun. No, I mean, I don't mean that sarcastically. Like, I do feel like feeling good about myself. Okay. So, let me see if I can do this in my head, though, right? Is this 168? Did I do it correctly in my head? I'm not even gonna use a calculator. I think I did, right? Yeah, 14, 28 plus 140, 168. Yeah, cool. I'm gonna call it. Cool, nice. Love it. Can I do electricity and magnetism? I can.
Well done.
Cross products, yes. I mean, do you think they wanted a vector for it? I don't think so. Yes, Newton meters. Oh. God damn it, I did fuck that up, sorry. It's Newton meters. Thank you. Thank you, Olaf. Femvox is my solutions manual, honestly. Okay, cool. That was yo boy. But again, if you're watching my stream here and you're in like middle school or high school and you're looking at some of these questions and being like, what the hell is going on? It's okay. Don't worry. Some people ask really complicated questions. Some people ask really simple questions. Everybody learns. So please do not feel intimidated. You can post whatever you want. I'm not going to say you're stupid. No one's going to say you're stupid. And we'll do the question. We want to make sure you learn. Why gamma? That's just what we use in physics. We use this for torque. We use gamma. I'm sorry. It's just what we do. The other one is this. I don't like this. The tau. I use gamma. I think it's gamma. No. No, it's gamma. Gamma for torque. Okay, whatever. I've always been taught that it's gamma. I don't know. Maybe someone taught me wrong. I'm sorry, my PhD is void. No. Some people are posing intimidating questions, yeah. Okay, maybe it is tau. I'm used to gamma. I don't know. Someone taught me gamma, and I've picked up the habit since. Solve some Lagrangian mechanics. I did some the other day. I did some Lagrangian mechanics. I totally did. All right, let's see. We got 27 minutes left. I'm going to try to go through everyone's questions. Oh, you have a fluids questions. Drew has this one. Okay, maybe this one. We can try this one. This is from you, Drew. And then Tommy, I see we're going to do a fluids question for you. Can I appreciate the solution? Let me go see it. Which one was that? This is the Bessel function one you did? Bro, worst problem ever. Oh my god. Dude, what the fuck is all this shit, dude? What? Oh my god, dude, what? Oh, JC, sorry, you can curse. Sorry. Let me give you that. Can say bad words. There you go. Now you can curse. You can say whatever you want. Sorry, I had to give you the roll. That's just a thing to prevent spammers and stuff who first come into our server from just yelling fuck all the time. Okay, nice. This looks impressive though, dude. Thank you. I love cursing. Well, you can curse all you want, dude. Yeah, this is... I say we're not like family friendly, but we're like kid friendly. I don't say anything that the kids don't hear anyways. That was a great question I was talking about. Is it a hard one, man? Are you gonna hurt me with this question though, bro? Don't hurt me, man. Okay. Heterocyclic reactions. I don't even know what that is, dude. What? Okay, a hinge structure consists of two lengths of length 2L. One end is attached to the wall. The other is moving at a distance 3L from the wall at a constant vertical velocity V0. Find the acceleration of the hinge. Okay. Acceleration of the hinge. So right here, we want acceleration of this. Connecting the links. When the link closer to the wall is horizontal. Okay, so when this one is horizontal. Oh, I assume so, right? The link closer to the wall. And then, when the velocity of the connection point is 0. You should add me on Hinge.
You done messed up, Aaron!
No, dude. The swiping, dude, it never ends. I haven't been on a dating app since like 2014. I refuse. It's all just catfishes anyways. I don't have Hinge, please no. Okay, how do we do this? I think this is something with like center of mass. Right? Or maybe, okay, let's try to like relate the things. Okay. Let's, I'm going to define a coordinate system because I know everything has to have a length of 2L, right? Nice, dude. Welcome, dude, Alec. The algorithm brought you here. Yes. Come stay. We got cookies. We're doing math. I'm doing math for another 27 minutes. Or physics, or whatever. No one's asked me a chem question yet today. What's up, AD? Good to see you again. Alright, let's call this 0, 0. And then let's call the hinge, because that's the only thing I really care about, as like x comma y. Then I know this point is going to be like some other x. Oh, but wait. The x is always 3L. Ooh. Nice. You're just cruising? Well, welcome, dude. Yeah, make sure like, subscribe, turn on the notifications. We stream 5 times a week. So if you want to learn or like get help with your math or science homework, we'll do it here on stream. And then I need like a y coordinate for this. Okay, I'm going to call this... Call this like capital Y maybe, right? Let's call it capital Y. This will be like lowercase y. Alright, cool. Now some requirements here, right? This distance always has to be 2L. We'll get some angles too. Yeah, let me see if I need them yet. So from this, I know that like x squared plus y squared has to equal to 4L squared. And then also 3L minus x squared plus big Y minus little y squared must also equal 4L squared, right? We agree with that? Math gaming. Yeah, Twitch, math, awesome. The algorithm kidnapped me and makes me watch this. Nice, yeah, you have to. You will learn math, you will like it. Okay, what do they tell me? Okay, find the acceleration when the link closer to the wall is horizontal. Oh, that tells me some cool stuff, right? That tells me that, when this one is horizontal, that means y is equal to 0, right? Okay, cool. And then when the velocity of the connection point is 0, that tells me when like dx dt and d little y dt is also equal to 0. Oh. Okay. I think what we want to talk about though is... V equals R omega. Do you think I want to do that? Glad to be watching this over brain rot. I agree. Wait, so we can make a triangle? We might be able to. Okay. Let me try to come up with... Because I know at the end of the day, right, if I want to figure out the acceleration of the hinge, I need to know, like, I need to know d squared x dt squared, and I need to know d squared y dt squared, right? This will help me figure out the acceleration of the hinge. So maybe let's, like, take some derivatives. I like yours, DMs. Yeah, you can drop whatever. We can go through it. Okay. Oh, okay. Whoa. The other one is moving at a constant vertical velocity. Okay, so we already know what dy dt is, right? That's equal to v naught. Yeah? And then that tells me that d squared y dt squared is equal to 0. Maybe r and theta? Are you thinking about, like, connecting this? And then, like, calling this, like, theta? And then saying, like, r sine theta is equal to, like, this thing? And then, but wait, how would that help me with this then? I don't know what this is. Drew, you submitted this. You tell me maybe what this is, right? Oh, the submission queue. Oh, sorry. Let me. Well, oh, that's because someone typed Q. If you type Q, that happens. Sorry. The middle hinge can only move on a circle. You just need the angular position as a function of the velocity v. Oh, I see what you're saying. I see. If I have time click void. You're saying this, right? You're saying this can only move along here. That is true. But then how do we relate that with the other one, though? Because then that's like another triangle, another circle. And then we're talking about like two circles. Right? Well, actually, no, because it's restricted to this. Oh. I take that back. Well. Yeah, what? Excuse me? Oh, no. Oh, you didn't get this? Okay. Well, here. So, let me explain that real quick. Yeah, but that circle moves. Yeah. I think we want to keep things in Cartesian. Let's see. So, for Roshan, if this coordinate point is 0, 0, I'm going to call this point like x comma y. And then this thing, because it's restricted to move along this, this has an x coordinate of 3L, and then it has a y, a y coordinate of, I'm just gonna say big Y. So the distance of this one, right, is like x1 minus x2 squared plus y2 minus y1 squared, and then square rooted. So that's this. That's how you get that distance. And then for this 2L, okay, that's equal to the distance between these 2 points. So that's x minus x squared plus y minus y squared. And that also equals a 4L squared. And then what I'm noticing here is that they do say that this moves at a constant velocity v naught in the y direction. So I know that d big Y dt is equal to v naught. So the second derivative of that is 0. Right. Well, I think I want something in general. I want a general equation, and then we'll come up with, like, expressions. Okay? Sorry, I'm answering my chat. Can we do real analysis? I have other streamers that do real analysis. Not me. I don't do real analysis. Okay. Acceleration in part E is v naught squared over 2L to the left. Okay, interesting. So wait, when the link is horizontal, so that's when this is happening, you're saying, right? Oh, I see. Okay, so when this is here, right? Then this has to be at a, this has to be 2L, I guess, as well, right? And then this distance is L. Or I guess it could be the other way, right? Sorry, it could be... Could be here as well, yeah? Two L. And then are you doing something with... When I see v squared over r, that to me... Yeah, that makes me think about centripetal acceleration. Oh, interesting. Wait a minute. Because, okay, this has a velocity component v naught, right? Or v naught's going this way. And the acceleration needs to be towards the origin, right? Because this is moving in circular movement, which is like, that's what, Jorgen, you said, right? You talked about that? Uh-huh. Okay. Yeah, because the hinge is constrained to move in a circle. Correct. I agree with that.
Good job.
And then how do we know that the linear velocity of it is v naught, though? Is that because the part connecting it is also v naught? Right? If this is v naught going up, oh, then this must also be v naught going up, right? Tangentially. Yes, okay, cool. Okay, nice, I like that. I agree with that. Okay, so, part A is just, yeah, v naught squared over 2L, right? I agree with that. That's cool. And then we say the velocity... find the acceleration of the hinge. The velocity of the connection point is 0? Oh, isn't the acceleration just 0 then? Well, I guess it has nonlinear fucking, what is it? Non-uniform linear velocity. Yeah. Drew, do you know the answer for part B? You have a hint for me at least? Velocity of the connection point is 0. Oh! Wait. Both answers are the same. Oh, it's always v naught squared over 2L? Wait, and this one is wrong? Wait, what do you mean this one's wrong? Exactly, I agree. But wait, the outer bar can't be horizontal, can it? How is this thing going to be horizontal? If this is... Oh, if this is 2L... I see. And then this is going to be 2L, and then this is L. Oh. It's going to be horizontal way up top. Yeah, exactly. Find the angles in the triangles. Alright, one sec. Let me see. What's our Q at? Let me see if I can answer anyone's real quick. Oh, Julord, Teams Greater, Yadavir. Fuck. And then, Tommy, I wanted to do your fluids question. Okay. Okay. in the triangles, he says. Okay. In the horizontal figure. Oh, okay. Okay, well, in the horizontal figure, this is 2L. And then this part has to be L. So this part here is equal to like 2L, approximately. So what? This is like square root of 3 L. And this is the, what, the 53, 37, 90 triangle, right? Just when the outer rod is horizontal. Yeah, I agree with that. Because as Jorgen pointed out, this we can relate the velocities of the end of the rod. Now it is the rod we can apply constraint and find the velocity of the hinge. Angles have a minimum and maximum value with V stuck in the Y direction. Yes, velocity is always in the Y direction. I agree with that. Oh, thanks, Andrew. I appreciate that, dude. Appreciate that I've helped you. I agree the length of the rod can't be changed. Component of velocity along... Yes, no, I agree. Well, yeah, this is always V naught, right? You can definitely ask a linear algebra question. I might not get to it today, but it'll go in my Discord, and I'll go over it later. This is going up by V naught. And then, I'm confused what you talk about, like, components. Because I'm trying to think about, like, what's always the tangential velocity of this thing, right? So, for instance, we're right here. I want this tangential velocity to get, like, V squared over 2L. Oh, wait a minute. Oh, but that's always this. Sorry, is that what you're telling me, Drew? Yeah, no, we're going to finish this one real quick here. No. Oh, I think I see what he's telling me. Yeah, this is always V naught. I get it. But no. This velocity in this direction will change, right? Because I want the component of this velocity that points in this direction. That's what we're saying, yeah? So, when they're horizontal, this is going up by V naught. But that doesn't... Okay. I'm cool with that being like that. Yeah, what is along the... There are two fucking rods, dude. What's along the rod? Which rod? At hinge and point V naught. Okay, you're saying along this rod. No, there's no gravity. This is the same? Yeah, not quite. The components at the tangent of the circle change at the other end of the second rod. That's the velocity along the circle. Yeah, in the horizontal picture here, right? This makes sense. This velocity is this. I agree with that. Right? Because this component is up, down, and we know horizontally tangent is also up, down. Psycho says, I think A is correct. Yeah. Okay, the question is part B. Which is... I agree. But does this always point tangent to where it's going? It doesn't, though. Nice. Yeah, just watch. Yeah, exactly. Sit back, relax, watch the math. Although I might give up on this question. We got part A at least. Maybe find the angle. Okay. Yeah, let's do that. Okay, fine. Well, but I don't know where the 0 is. Find the angle where it's going. So find theta dot. Find theta dot here. Yeah. Is it just asking for the acceleration upwards? When you get to the topmost point, it can go, it's orthogonal. Yeah, and it's not always tangent. I agree. Okay, I'm running out of time on this one, and we have spent a lot of time. We got part A right, so I'm going to count it as good for now. If you want to keep answering this one, Drew, please answer my Discord.
Good job.
I think, yeah. Just because, yeah, I'm not getting it, and I have 7 minutes left. It's okay. The link stuff is weird. Okay, cool. Also, oh, we already did one of your questions, Drew. What? I did 2 for you today. How do you submit? Actualofficehours.com. That website down there has the way to submit. Let me look at what we got. Because I got 7 minutes, so I'm going to go through what I think I can do quickly in 7 minutes. Engineering question with fluids. No, I see momentum flux correction factors. Oh god, no. I'm sorry, Tommy. I don't think I can do this in 7 minutes. The expansion of this is running descendant powers of x. The first 3 is given that a and b and c are positive. Find the values of a, b, and c. Yeah, I just want something nice. Okay, I'm gonna see if there's something just like real quick I know I can solve. I know I can solve yours, DM squared. Yeah, no, submit it to the website. Submit it to the website. I need it in the website here. You can submit it to the homework help, but it won't come up on the stream. Punnett square? What do you wait, is this doing? Oh, this is so cute. Is this like biology? And then what did click void have? This. Oh my god. You guys are hitting me with everything just really difficult all of a sudden. Okay, I'm gonna help Julort out. At least. I think I can do this one real quick for you, Julort. We're taking a little break from all the really difficult math questions real fast. I want to feel nice about myself. I only have a minute left. Yeah, I gotta go soon. Okay, here we go, Julort. And then I'll post the rest in the Discord if you guys want to go over them while I'm gone. All right, $5 per ticket and sells 250 tickets after checking the prices and number of tickets. That every $1 increase results in 10 less customers. Okay, that's very cool. Yes, it's a price, supply, and demand. This is pretty cool. Let X be the ticket price. Use the market research on ticket price and customers to write a linear function to represent the number of tickets sold in X. Assumed a 1-to-1 ratio of customers to tickets. Hint, use slope-intercept form. The slope and 1 point you're given, you will need to solve for the y-intercept B. Okay, cool. Okay. So let's use X. No, let's say X is the ticket price. Okay. So this is this, and this is this. So I already know this. I already know 5, 250, right? That's one of the points. Yeah, no, I think maybe it messed up. No. Mathematic Fanatic, I think you're right. I think the clock, like, hung for a bit. I gotta work. That's also vibe coded. I gotta probably fix that. Okay. Okay, what it says. for every $1 increase, so for every when delta x is equal to 1, the number of tickets delta y goes down by 10, okay? So then you know delta y over delta x, which is equal to the slope, is equal to negative 10. So then y is equal to negative 10x plus b, and then you plug in a point here. So 250 equals negative 50 plus b. So b is equal to 300. So here's your linear function, Jalort. You have y is equal to negative 10x plus 300. That's part A. Total revenue is equal to number of tickets sold times the ticket price. Oh, very cool. Write in a function Rx. Good. So Rx is equal to the number of tickets sold, that's y, times the ticket price. That's going to equal this times x. So that's negative 10x squared plus 300x. Okay. Nice. Yes. Yeah, you click students to sign up. Yeah, great. Yeah. That's good. But for during the live stream, there's a website. The pin there should say, like, how to submit questions during the live stream. I'll try to do your question, like, in the off period. Okay, cool. That's part B. Let me see if I have no time left, but I will try to just round this one out real quick for you, Jalort. I'm going to get it for you. Introduce variables. Here we go. You're doing them right now. What ticket price will maximize revenue? Oh, this is cool. Okay. So this is when R of X is a max. Which, if we write this out, this is going to be negative 10. And that's going to be x squared minus 30x. And then you got to complete the square on this, Julort. You're good, Julio. Yeah. You want to get this in vertex form. I could do it with calculus, but I don't think you know calculus yet. So what I did is I pulled a negative 10 out of both. So this is going to be the vertex. Because this is already going to look something like this, and you're looking for like the top part. So divide by 2. And then square it. So we're going to do plus 15 squared minus 15 squared. And so that's going to give me negative 10 x minus 15 squared plus 10 times 15 squared. So I turned this into this, and then I multiplied this through on both. Okay, so the ticket price, that's where the vertex is. And the vertex is x minus h squared plus k. There you go. That's the vertex. So that's going to be when x is equal to 15. So $15. What's the maximum possible revenue? That's the y coordinate of the vertex, right? Let's see if we understand why that is, right? This is like h comma k. And that's this part. And so that's going to be 2,500. Wait, sorry. 15 times 15 is 225? 2250, yeah? Cool. If total revenue is $2,000, what are two possible scenarios? This is cool. So you say 2,000 is equal to negative 10x squared plus 300x. And then this is the quadratic formula. You can divide through by 10. You get 200 is equal to negative x squared plus 30x. X squared minus 30x plus 200 equals 0. Fucking factors of that. Is there anything that does that, boys? I don't know. Fuck. That is kind of funny. Is it 40 and 50? No, 40 and 50, no. I think you just have to, like, graph this. So what's that? That's x squared minus 30x plus 200. And then Cool, that happens at 2 different places. Oh, 10 and 20. Oh, duh. I'm retarded. Sorry. Okay, yeah. Yeah, okay. Minus 10, minus 20. So you get x minus 10, x minus 20. Yeah, I don't even know why I needed that. Okay, so x equals $10 or x equals $20. And you're done. Good job, Julio. Good question. Appreciate it.
That's dope.
All right, I really got to go. So let's close out the stream. All right, thank you, everyone, for coming to Actual Education Office Hours. Appreciate all the questions. Stream is ending now, but if you want to submit your question for us to go over later, go to www.actualofficehours.com, and we will get it into our Discord. So here on Discord, any questions that I don't answer today, because we went through a lot today, but I can't do everything. I'm not completely all-powerful. So what I'm going to do is I'm going to post 6 in. I'm going to delete 6. What time do we stream? Yes, so if you go here to the website, actualofficehours.com, you can click here on the streaming schedule button, and that will show you a calendar of like when we stream. So our next stream is tomorrow, starting at 4 o'clock Pacific. And then Zach will have a math stream on Saturday. And I'm hoping to add more streamers here. So if you want to help out and want to stream math and science help, join our Discord, and I will be making an announcement in the Discord soon for like recruiting people that want to maybe hop on this awesome bandwagon of help and fun. So here, I'm going to post all the questions. And that should have posted all of them. Good. Posted 6, and I just cleared them all. You're very welcome. Okay, cool. I appreciate all you guys for finding me and whatnot. Yeah, we do this 5 times a week, so our next stream will be tomorrow. Make sure you like, subscribe, turn on notifications. All that awesome stuff helps us move up in the algorithm and make sure that other students who are doom scrolling on YouTube or TikTok or Twitch see us instead. So, love it. Yes. I would love to. Yes, Mathematic Fanatic, 100%. All right, what we're going to do, if you're watching us on Twitch, which is the better platform because it's horizontal, I understand a lot of you probably found us on YouTube because their discovery algorithm is better, but make sure when you go to that website, you can also join our Discord and watch live on Twitch. Go at us on Twitch as well. Twitch is great. We're going to go follow somebody who is on right now. Who do I want to say hi to? Science? Yeah, let's go say hi to Science. I think Science is great. Science is great. Cool. Say hi to Science. Okay, cool. All right. Thank you, Drew, for posting the solution. We'll see it. All right. Enjoy the rest of your Wednesday. We will see you tomorrow. Peace.